Show that x plus 1 is a factor of x squared minus 7x minus 8. Now, we should know how to factorise this quadratic here already. It would be x plus 1, x minus 8. Now, you could just multiply those two together and that would prove that this is a factor of this quadratic. Another way of doing it is that if you know that x plus 1 is a factor, then you must know that minus 1 would be a root. So if you evaluate the function by entering minus 1, then it should give you 0 if indeed minus 1 is a factor and x plus 1 is a root. So if we test that, we'll have minus 1 squared minus 7 times minus 1 plus, take away 8, sorry. So that'll be 1 plus 7 take away 8. And that does give us 0. And therefore that proves that minus 1 is a root and that x plus 1 is a factor of this quadratic here. Another way of doing that is by division, and by directly dividing x squared minus 7x minus 8 by its factor x plus 1. So we can do this by long division. So if we divide x squared minus 7x minus 8 by x plus 1, so we'll begin by dividing x squared, the highest power of x available, by the first x term, which will give us x. Multiplying back gives us x times x is x squared, and x times 1 is just 1x. Subtraction, x squared minus x squared is nothing, and minus 7x, take away this x, gives us minus 8x. Then pull down the minus 8. Now we'll divide the highest power of x, which is this here, by x to give us minus 8. And we'll multiply back to make sure we've got no remainder. Minus 8 times x is minus 8x. And minus 8 times 1 is minus 8. Minus 8x, take away your minus 8x now, will add together to give you nothing. And minus 8, take away the minus 8, will add together also to give you nothing. So there's no remainder. And that tells us that x plus 1 must be a factor of this because it divides perfectly in with no remainder. And as we already knew in the first place, it's just an example really, that x plus 1, x minus 8 are the factors of x squared minus 7x minus 8. So show that x minus 3 is a factor of this cubic then. Well, one way to do that is just to enter the root. So if the root gives us a value of 0, then then 3 must be a root, and therefore x minus 3 must be a factor. So if we test that first of all, so we'll have 27 minus 36 plus 3 plus 6, and that does give us 0, and that shows that 3 is definitely a factor of that. Another way of showing that x minus 3 is a factor is by division. So I'm going to divide this cubic by x minus 3. So set it up. And then we'll begin by dividing x into the first power of x in the cubic. So x cubed divided by x will give us x squared. Then we'll multiply it back. X squared times x is x cubed. And x squared times minus 3 is minus 3x squared. By subtraction, x cubed minus x cubed is nothing, and minus 4x squared minus 3x squared becomes just minus x squared. Bring down the next term. Divide the highest power of x, which is this, by the first term, so that will become minus x. Multiplying back, minus x times by x is minus x squared. Minus x times minus 3 becomes positive 3x. By subtraction, minus x squared minus x squared will add and then therefore disappear, and x take away 3x will become minus 2x. Bring down the next term. New highest power of x divided by x will give us minus 2. And then we'll multiply just to make sure we've got no remainders. Minus 2 times x is minus 2x. And minus 2 times minus 3 is positive 6. Subtraction leaves us with nothing. So that tells us that x minus 3 is a factor because it divides imperfectly by x minus 3, x squared minus x minus 2. holding that thought for a minute, if we have already used division to get ourselves to this point, we should be able to solve this equation. And we've got a factor here, and then we've also now got quadratic. Now that quadratic could be solved by factorising, or if that's not an option, completing the square or the quadratic formula, just like any regular quadratic. So this one does factorise quite nicely here, so we can do that. So that will become x minus 2, x plus 1. And therefore, if those are the factors, then the roots must be at 3, 2, and minus 1. Solve x cubed plus x squared minus 5x plus 3 equals 0. So this time we've been given none of the factors, so we need to go and find at least one of them using a bit of logic and trial and improvement. Once we've done that, we can then get the others by division. The fact this ends in 3, though, tells us that there's not very many ways of making 3, especially given the fact there's no coefficients of these front terms. So it makes sense to try by 3 and minus 3, because they're the most likely ways we're going to get there. So if we try the root of 3, which of course means that we're suggesting that x minus 3 might be a factor, that would give us 3 cubed plus 3 squared minus 5 times 3 plus 3, which would be 27 plus 9 minus 15 plus 3, which is 24. And therefore 3 is not a root, and therefore x minus 3 is not a factor. If we try minus 3, we get minus 3 cubed plus minus 3 squared minus 5 times minus 3 plus 3, which would be minus 27 plus 9 plus 15 plus 3, which does equal 0. And therefore minus 3 is a factor, and more importantly for us, minus 3 is a root, and more importantly for us, x plus 3 is a factor. And if x plus 3 is a factor, then we can use that to find the other factors by using a bit of division. So we're going to divide this cubic up into x plus 3, and that will give us something we can solve. So we'll begin with the highest power of x, and divide that by x, we get x squared, multiplying back out gives us x cubed plus 3x squared. Subtraction, the cube term will cancel, and then x squared minus 3x squared will give us minus 2x squared. And we'll pull down the next term. Minus 2x squared divided by x will give us minus 2x. Multiplying back out, minus 2x times x is minus 2x squared, and minus 2x times 3 becomes becomes minus 6x. Jumping the gun a bit there. Subtraction, minus 2x squared minus 2x squared will cancel, and minus 5x minus 6x will mean we'll be adding these two together. So minus 5x add 6x will just become x. Bring the next term down, we've got x plus 3. New highest power of x here, divided by x, will give us 1. And then multiplying back out, 1 times x is x, and 1 times 3 is 3. So there's no remainder when I subtract those final two. So what that tells us is that x plus 3 multiplied by x squared minus 2x plus 1 all equals 0. And we've got a nice quadratic here, which we will hopefully solve by factorising, but if not, completing the square or the formula, we should get you there. But this one comes apart quite nicely by factorising. That is the repeated factor of x minus 1. And therefore, as a result, the roots and the values of x that solve this are x is minus 3, and then the repeated root of 1.